Why would you want to find your car keys and leave the quarantine when you can find rational zeros from home? Here we're doing 6.6. So the rational zero theorem allows us to take any sort of function we have. So basically these things look like a big giant version of an and then x to the n. The significance of that is that that's just whatever the term is. So like say this is a fifth degree equation, then this would be, the coefficient that goes with that x to the 5, and then we'd have another one x to the 4, another one x to the 3, blah, 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 until we get down to a1, which is x to the first, and then a0, which is our constant. So when we're looking at these things, no different than anything we've seen before. That's just the notation for it. In terms of all of these, they have integer coefficients, so basically there's no like 1/2 x stuff here, and every rational zero of f has the following form. So there may be some irrational zeros, which we can talk about a little bit later, but for all the rational ones, they're going to be p over q. So the p thing is just the factor of the constant term. So when we're looking at this, all I'm saying is in my equation, that is my p, which is this thing here. And then the q is the leading coefficient in front of my highest degree x, and that is this thing here. So let's say, just for example, to come up with a really quick one here, I've got f of x equals 2x to the third, plus x minus 5. Sure. This p here, or excuse me, my q value, underline this here, get all the same colors going on. So here is my, q value. And now here is my p value. So when I am looking at these, it has the following form of p over q, and I want to be able to list out the different possibilities. So this is a factor of the constant term and a factor of the leading coefficient. So with this factor, okay, what makes up 2? So I started with an easy one here. So what makes up 2 is just 1 and 2. And what makes up 5 is 1 and 5. And now why have I ignored the negative here? Because I'm going to have plus minus for both of these things. So the reason I'm going to have positive and negative is because I could have negative 1 times negative 2. That'll give me a positive 2. Or I could have positive 1 and positive 2. So all of my factors for 2, aka the green thing here, the q, are going to be positive 1, negative 1, positive 2, negative 2. In terms of my p-value, for my 5 here, it's going to be the same thing. So I would have a positive 1 and a negative 5, or a negative 1 and a positive 5. So these are all my possible factors here. Now in terms of coming up with what these things are going to be, it's going to be included in all of the different possibilities. So I'm going to split this thing up. Let's actually scroll down a little bit. So I'm going to split this thing up into, I'm going to have my p's here, and I'm going to put my q's here. So when I'm looking at these, for the possible q's, I had either 1 or 2, and my possible p's, I had 1 or 5. So again, just kind of like splitting it here, so I can just list these things out. So as I'm trying to list out all of my possible rational zeros, it's just going to be every combination of these factors. So when I'm listing these things out, I'm going to do all of my possible p's, so I'm going to do these in red. So I could have 1 over something, or I could have 1 over something, or I could have 5 over something, and 5 over something. The something is the q value. So here I'm going to say over 1, over 1, over 2, over 2. Now keep in mind that each of these things is going to be positive or negative. So we actually have 8 here. So if I wanted to list all these things out, I would typically simplify. So 1 over 1 is just 1. So I'd say I get plus or minus 1. And I also get plus or minus 1/2. And, oops, that's not a good 2. That's better. I get plus or minus 5 over 1 is just 5. And then I also get plus or minus 5 over 2 as we try and sneak it in there. So this is the list of all of the possible rational zeros. Again, rational just being like a nice fraction. It may be a constant itself, like 3 or 5, but it may be like 2/3 or 7/8 or whatever. When I'm looking at irrational things, it'd be like root 2 or root 3, things like that. So when I'm coming up with this list, it's just all of my possible p factors over all of my possible q factors. So that's where this part is coming into play here. Yellow is not a phenomenal color to outline on top of white, so there we go. So again, all my possible factors for p over all my possible factors for q. Now, this does not mean that these will all be zeros. These are just all of the possible zeros. So I would then have to go through and test each of these things. It may be the case that none of them works. So that's also, just a possibility for us. So let's look at an example here. This is kind of our intro, but let's look at our first example. So the first one we're looking at here is for this function. So the first thing I want to do is I want to identify what my, let's do this, separate here. I want to separate what my p and my q values are. So I'm going to use the same, what do I use for colors? P's in red, okay. So I'll keep my p in red and my q in green. So my p value here is going to equal 12, and my q value here is, again, the leading coefficient. In front of this, there's actually just a 1. So if I don't see a number there in front of my q, it means it's a 1. So now as I look to these, I'm looking to figure out what all the different factors are so I can come up with a list of my possible rational zeros. So again, as I do this thing, I'm going to have all my possible p's over all my possible q's. So let's write this out. For my p's, what are my factors for 12? So 12 can be broken down into, should have given myself a little bit more room. So I can do 1 and 12, I could do 2 and 6, or I could do 3 and 4. So in terms of breaking this thing down, all my different possible p factors, I could have 1, 2, 3, 4, 6, and 12. And now in terms of my different possible q factors here, I guess I should do that in another color. So again, just a method of organizing all these things. You don't have to do this if you don't like it. So for my q's now, it's just going to be the 1, which is pretty straightforward. So all of these p's over all of these q's is end up just going to be 1, and we'd say over 1, 2 over 1, 3 over 1, and all these things are just going to end up being the numbers themselves because I'm just dividing by 1 each time. Kind of boring, but I will still write it out for you. So all my q's here, 1, 1, oops, that should be in green. Then I also want to include that for each of these, it's going to be plus or minus. So plus minus, plus minus, plus minus. Cool. So if I were to come up with a full list of these things, now I'd say I get 1, 2, 3, 4, 6, and 12. So now I'm going to test out each of these within this function. So again, within this function here, I'm going to write this out and I'm going to start using synthetic division to do it. So as I test these things, I'm literally just going through and eliminating them as I go. We also want to be careful to check things multiple times because although it may work once, it may work twice. So we'll get to a little bit more of that stuff later on. But for right now, I'm going to start with the first one here. I'm going to try 1. So I'm going to try is 1 a 0 here. So I'm going to take my equation here and I'm going to do synthetic division for it. So we were doing the box and setting this up, and I'm going to use 1 for my first 0. So if I put a 1 in here, my equation that I'm working with is going to give me a 1 for my leading coefficient here, 2 for my leading coefficient there, then I get negative 11, and then I've got negative 12. Again, this is coming from this equation, x to the third plus 2x squared minus 11x minus 12. So that's where these numbers are coming from. I am choosing the 1 to start. So I have plus minus 1, plus minus 2, blah, 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 for all these different possibilities. I'm just going to try 1, see if it works. So with 1, basically what happens is I get my 1 to drop down. Oh, that's a little too close to the yellow. Let's do pink. So 1 just comes down. I do 1 times 1 gives me 1. Add these up, I get 3. 3 times 1 is 3. Add these things up, I get negative 8. Negative 8 times 1 is negative 8. And I get negative 20. So if it was a 0, this would be 0. We see that it is not. So therefore, 1 is not one of my zeros. It was a possible, and then we tested it and found out that it's not. Okay, move on to the next one. So the next one we're going to do is we will try negative 1. So let's try negative 1. So you can see that this process may become a little bit tedious. So I would suggest before we go through and do all of these things that we take a peek at the graph and see what the thing looks like, and maybe we can get an idea of what they're going to be. Now again, this kind of goes counterintuitive to what we're trying to teach here, but I think it's worth showing you and definitely a huge time saver. So here's the graph for this equation. I'm just using Desmos to do this. So I have x cubed plus 2x squared minus 11x minus 12. I've zoomed out to show you in general what this graph looks like, and now I want to focus on this. I see a 0 here at negative 4, a 0 here at negative 1, and a 0 here at 3. So I've got a pretty good suspicion here that negative 1 is going to work out for me. So as I go through and do this, do it in pink again, 1 just drops down to be 1. 1 times negative 1 is negative 1. Add these things up, I get 1 times negative 1 is negative 1. Here I get negative 12 times negative 1 gives me 12. And now I got a 0. So what does that mean? That means that negative 1 is one of my zeros. So I'm just going to jot that down right here. So negative 1 is one of my zeros. Now in terms of what that'll turn into for a factor, if I were trying to factor this thing, the factor would look like x plus 1. So just keep that in mind, but negative 1 is one of my zeros, and that's what I'm trying to figure out. So let's scroll down a smidge here and look at this thing. So now that I've got this, what does that mean? Well, 1, 1, negative 12 here represents x squared plus x minus 12. And now I would look at this thing and say, okay, is there a way that I can solve this? Again, trying to solve for zeros, so set equal to 0. I'd say, yeah, I think I can factor this thing. I think it factors into x plus 4 and x minus 3. Again, each of those are going to be set equal to 0 individually, so I get answers of x equals negative 4, and I get x equals a positive 3. So these are my other 2 zeros that I'm going to include in my list. So I'm going to jump back up just a smidge here, and I've got negative 1, and I've also got my negative 4 and my 3. So now here are my 3 zeros, and therefore my answers to this question. So again, we're saying find the rational zeros of this thing. Well, this is what they possibly could have been, right? All of my possible rational zeros, and then I go through and I figure out one that works. So once I got this one that worked, I got it down to a quadratic. So cubic stuff, pretty hard to factor. Quadratic stuff, we're really good at. So even if I had to use my quadratic equation here, that's totally fine. We can use the quadratic formula to solve for this thing if it's going to be messy, but it's worth a shot to try and factor it first. Let's give ourselves a little bit more space here. So let's grab all of these things and pull it down through the magic of computers. Cool. All right, so now we gave ourselves a little bit of breathing room here. Let's look at another example. So in this example here, we're trying to use this equation and we're trying to find all real zeros. So the reason that all real zeros is what I'm emphasizing here is that this is different than all of my rational zeros. Rational zeros means nice numbers, right? 5, -5, 2, -2, 1/2, -1/2, whatever. But for my real zeros, I may get to a point where once I've gotten all of my like semi-clean answers, like all of my fractions and constants like that, my integers that I've got, then I may get to a point where it gets messy. So now let's take a peek at this thing. So I've got a graph of this right here. And as we look at this thing, this is just in general what it looks like, big W. What I'm focusing in on is this -1.5, -618. I don't know that this is going to be very nice. And here I get 0.8, looks kind of nice. And I get 1.618. So again, this is not looking clean. This is not looking clean, but my -1.5 does, and my positive 0.8 does. So I'm just going to represent those two things right here. So when I talk about -1.5, let's do it typing out so my handwriting is legible. That's the same thing as saying -3/2. So I've got that one, and I've also got this positive 0.8, which is 4/5. So I got these two zeros from looking at my graph. Now again, we don't want to bank on just the graph telling us everything, but maybe I start using these ones and it would save me a lot of time, because there's no way I want to go through all the possible rational zeros for something that starts with a 10 and ends with a 12. That's a nightmare, right? I have to do all of my factors of 10 on the bottom and all of my factors of 12 on the bottom. Absolute pain in the neck. So I'm going to just skip writing this stuff out and just highlight the fact that, what did we do? We did this one in red, I believe. So there's my P, and we did Q here. So again, all of my P's over all of my Q's. So all the factors for 12, aka 1, whoops, do it in red here. So 1, 2, 3, 4, 6, and 12 like we got before, and then factors for 10 are going to be 1, 2, 5, and 10. So it's going to be 1 over each of these things, and then 2 over each of these things, and then 3 over each of these things, and that's where it generates this list down here. I can go through and I can simplify, right? So if I had 1/1, that's the same thing as saying 2/2. So I'm not going to have an exact multiplication between these two things. It's going to be some simplified version of that because I'm going to have some overlapping. So with that in mind, we want to kind of take a peek at what our graph would be. We did that. We got these two values. We got -1/2 that we're going to check out, and 0.8, which is -3/2 and 4/5. So when we're looking at these things, these are really the ones we want to keep an eye out for. Let's see, in our list here. So I don't even think this is a complete list they have here, which is a little disappointing. So let's just start out with our -3/2. So we're going to be doing synthetic division with our -3/2. Again, our coefficients are coming from our equation here. So this 10x to the 4th, so we've got our 10, and then we've got -3, -29, 5, and 12. So the next thing we're going to do is actually just take our 10 and we're going to drop it down. So now I have 10 times -3/2, which is -15. Add those things up, I get -18. Whoops, there we go. And then I'm going to do again -3/2 times my 18, which will give me a positive 27. And I'll add these things up, I get -2. -2 times my -3/2 is just going to give me 3. And I'm going to add these things up, I get 8. 8 times -3/2 is going to give me -12. Add these things up and I get 0. So the thing that is important here is that I got a 0, therefore -3/2 is a 0 for this function. So as I look at this thing, one of my zeros is the -3/2. So now I'm going to keep going. When I keep going, I want to continue with what I've already got here. I don't want to go back to the beginning and start all over. Now that I've reduced this from a 4th degree to a 3rd degree, I'd want to continue from here. So the next one I'll do, I don't know, let's do our 0.8. So let's set it up and do it again. So here now I'm going to use my 4/5 here. Oops, there we go. And again, I'm going to be using these values, which were just the remainder from when I did the division here. So now I'm going to carry these over up top. So I've got 10, -18, -2, and 8. And I will start going through and doing my synthetic division. So I'm going to drop this down here. It is 10. 10 divided by 5, what gives me 2 times 4 is 8. Here now I get -10. Here now I would get -8. Gives me -10. Multiply by 4/5 gives me -8. Adds up to give me 0. Cool. So now as I look at this thing here, I'm saying this is left over. This 4/5 was another 0 of mine. We saw that it worked. So far I've got the 4/5 here that worked. I had the -3/2 that worked. And now I have a quadratic, which is 10x squared minus, 10x minus 10 equals 0. So at this point, I would just solve this thing. So the easiest way to me to look at this thing and solve is I say, okay, well, 10, 10, 10, I'm going to divide this whole thing by 10, and I end up getting x squared minus x minus 1 equals 0. So now from here, I got to try and solve this thing. So how do I solve this? I can look to try and factor it, but it doesn't not really look like it's going to factor nicely. So again, I would look at my -1 here and I'd say it splits into 1 and 1. 1's going to be negative, 1's positive. That's definitely not going to add to give me -1. So it's not going to be a nice thing. So I would do my quadratic formula. So here I'd get my a value of 1. My b value is -1. And then my c value is -1 as well. So now I'm going to punch this all in to -b plus or minus the square root of b squared minus 4ac, and that's all being divided by 2a. So now as I look at this thing, just plug in some numbers. So the negative with a -1 turns it into 1 plus or minus my -1 squared is just going to give me 1. I have 4 times, and then I have 1 times -1, so it's going to end up being plus 4, all divided by, now here I'm going to just get 2 times 1, which is 2. I'm going to simplify this, and I'm going to leave it as 1 plus or minus the square root of 5 over 2. Again, not nice zeros, but these are my other two zeros. So these are not rational, these are irrational zeros, but they're still zeros nonetheless. So in this problem, when we're finding all of our real zeros, I have one of them here, which is that -3/2. I have another one here, which is that 4/5, and then I have my other two right here, 1 plus or minus root 5 over 2. So we have two of them written here. If you want to write them out separately, you could, but I wouldn't bother. Last one here we're going to look at is an example using x to the third minus 2x squared. Note there not being an x here, minus 75. Okay, so let's do p values and q values. I forget which one I did in what color. I don't think it really matters much, but let's, yeah, q. So here I have an imaginary 1 sitting out in front that I don't see. Here my p value is 75. And we got our q value of 1. And now when we look at this thing, I'm going to say, okay, well, what are all my factors for 1? So it's just 1 and 1, so q is done. For 75, this thing could split out into 1 and 75. Whoa. It could also be, it's kind of a weird way that I'm writing it here. I'm trying to separate these things. 3 and 25. So now as I'm looking at this thing, oh, I also have 15s in here. 5 and 15. So now I've got all my list of possible factors. I'm going to do all of these combinations over all of these combinations. So 1 over 1, 3 over 1, 5 over 1, yada yada. And each of them is going to be plus or minus. So here it looks like we have a full list, whereas before the solution was missing the ones we wanted. So that was pretty inconvenient. So this does look like the right list here, which is nice. And now I want to start going through and plugging them in. So again, I don't feel like doing a ton of guesswork. So I'm going to check out what the graph looks like first. My graph here looks like a cubic thing. It's super zoomed out because these are very large values very quickly. But the thing that I'm going to hone in on is this 5. So I'm personally going to use a 5 to start out. So when I set this thing up, I'm going to be using 5 here. We're going to do our synthetic division and see if we luck out. I think that we will. So here we've got our 1 from the x cubed. I have negative 2 from my x squareds. I have to put a 0 in here. This is the biggest mistake I see people make, is they forget to put a 0 in for the x. And then I have negative 75. So now let's do our synthetic division out. So the 1 just drops down. 1 times 5 is 5. Add these things up, I get 3. 5 times 3 is 15. Add these things up, I get 15. 15 times 5 gives me 75. Add these things up, I get 0. Perfect. So I just found my 0 for this function. So here's one of them, and now I want to see what's left. So in terms of finding the other zeros, I'm at a quadratic. So let's turn this into x squared plus 3x plus 15. Again, this thing is set equal to 0. So as I look at this now, I'm saying, okay, well, maybe it factors nicely, maybe it doesn't. Factors of 15, both positive, that are giving me 3, not going to happen. So I'm going to turn to my quadratic formula. I'm going to do negative 3. So I'll write this out, but then I'll kind of like jump the gun here. A is 1, B is 3, C is 15. Same thing that we did before. So we're using our quadratic formula here. And we'll put it down here for reference for you. So again, just plugging these things in like this. So I'm going to end up getting negative 3. And then I'm going to get my plus or minus the square root. So my b squared value here is going to give me 9. Minus, so 4 times a times c. So now I'm saying 4 times 15 is going to, well, times 1 times 15 is going to give me 60. And now this is all being divided by 2 times 1, so 2. So we simplify this and we get negative 3 plus or minus square root of negative 51. If I have a negative root, this is not going to be a real answer. It's going to be an imaginary answer. So my answer for these zeros are imaginary zeros. It's negative 3 plus or minus, I would say I root 51. So again, the I is just taking care of that negative, what in the world? Why can't I get this to work? There we go. Over 2. So here are those other 2 zeros, and they're imaginary zeros. So in terms of like what I could have as a real answer for this, I'm never going to be able to use these imaginaries, although some problems in the future, wink wink, will involve finding all zeros, both real and imaginary. So just keep that in mind. This is still a totally fine answer. It's just that it's not going to apply to real world things. So this problem ends up being from this pyramid, and we're trying to create a pyramid, so I kind of just skipped to the equation here. But if you have something which you're actually plugging in, then obviously we only are able to use real answers. So here our only real answer is the 5. So in terms of possible rational solutions, we just get 5. For irrational imaginary stuff, we get the negative 3 plus or minus I root 51 over 2. So that is it for 6.6. Hopefully it was as fun as you had anticipated and worth staying home for.